guys, this is Archana from Edureka and I welcome you all to this session on manual testing interview questions. Testing is really crucial to success of any software product in this competitive world. Though automation testing is raised these days, unfortunately it cannot be applied in all the scenarios. No matter how good automated tests are, you cannot automate everything. And that is why manual tests play a very important role in software development as well as testing, and they come in handy whenever you have a case where you cannot use automation. Hence, there's a lot of demand for people with skills relevant to manual testing. This manual testing interview question session is the perfect guide for you to master manual testing. So without any delay, let's go ahead and take a look at today's agenda. To make it much more easier for you guys to understand, I've divided the questions into three categories: beginner level manual testing interview questions, advanced level questions, and lastly we have real world scenario based questions which are based on manual testing. So I hope agenda was clear to you guys. But before we actually get started, please do not forget to subscribe Edureka YouTube channel to stay updated with current trending technologies. So here we go. Let's begin with the first category of questions, which are beginner level questions. The first question that we have here is very basic. What is software testing? Explain in simple terms. Do you guys agree with me when I say every system has software bugs? Well, it's true, right? It's impossible to design and bring out a perfect software product. So software testing basically is the process of executing any sort of software or an application to find out if there are any bugs or some sort of errors in it. So before actually goes public, programmers spend hours trying to iron out every little bug there is. They check for any mistakes and problems in the design and the functionality of the software. Well, until then, product won't be available for commercial use in the market. So as the name already suggests, software testing means checking the developed software for any mistakes and problems in the initial design. Next up, we have a following question which says, why is software testing required and how does testing benefit an organization? Software testing is really a mandatory process which guarantees that software product is safe and good enough to be released to market for public to use it. Well, here are some compelling reasons to prove why testing is really needed. First of all, it points out the defects and errors that were made during the development phase. So basically, it provides a quality assurance. It reduces the coding cycles by identifying issues at the initial stage of development itself. It ensures that a software application requires lower maintenance cost and it results in more accurate, consistent, and very reliable results. Testing ensures that customer finds the organization more reliable and their satisfaction in the application is maintained continuously. Testing also makes sure that software is bug-free and the quality of the product meets the market standard. And lastly, it ensures that the application doesn't result in any failures that could be of some harm to people who are using it. So in this way, software testing is really required to bring out a high quality and safe product to market. Moving on to next question, we have, what are the two main categories of software testing? Well, software testing can be divided into multiple categories based on different scenarios, but mainly you can divide software testing into two types, which is manual testing and automation testing. So manual testing, it's pretty self-explanatory, which is testing of a web application is basically done by human action. That means someone actually goes on a device to evaluate numerous components like design, functionality, and performance of the application. But testing to find defects or bugs manually is really time consuming, right? It's expensive, it's often repetitive, and it's subjective to human error. And that is why automation testing comes into picture. Automation testing is well automated. If I have to tell, automation testing uses the assistance of tools, scripts, and software to perform test cases by repeating predefined actions. So these are two main categories of software testing: manual testing and automation testing. Next question that we have is, what exactly is quality control? There are different terms that are associated with quality when we are referring to software. You have quality control, quality assurance, and many more. So what exactly is quality control? Well, quality control is a product-oriented approach of running a program to check if it has any defects. The key point that you have to remember is it is product-oriented approach. So using quality control, testers make sure that the software meets all the requirements which are put forth by stakeholders and end users. It includes different type of testings, like you have functional testing like unit testing, usability and integration testing. You also have non-functional testing like compatibility, security and performance and all that. So quality control in general is a product oriented approach of running a program to determine if it has any defects or not. Moving on to our next question, it says what different types of manual testing are there? Well, basically, you have 6 types of manual testing, which are black box testing, white box testing, unit testing, system testing, acceptance testing, and integration testing. Well, let me explain you all of these types in a very brief manner. But if you want to know more, you can actually go ahead and refer to Edureka YouTube playlist on software testing. So what exactly is black box testing? In black box testing, testers analyze the functionality of the software or an application without actually knowing much about the internal design or structure of the application that they're testing. Talking about white box testing, unlike black box testing, white box requires a profound knowledge of code as it includes testing of some structural part of the application. Next up, you have unit testing. It's a way of testing the smallest piece of code, which we usually refer to as a unit. Then there's integration testing, where you test the interface between the units. After that, we have system testing, which is done to examine the fully working of an integrated software system against the user requirements. And lastly, we have UAT or acceptance testing. It's a formal testing that's performed based on user requirements and function processing. This type of testing, that's acceptance testing, it covers end users' real world scenarios. So yeah, these are 6 typical types of manual testing. Moving on to our next question, explain the difference between alpha testing and beta testing. Well, both alpha and beta testing are customer validation methodologies. On top of that, both of our acceptance testing types. They help in building confidence to launch the product in the market, and that's how they result in success of product in the market. So what exactly is alpha testing? Alpha testing is internal acceptance testing, which is performed to identify all possible issues and bugs after acceptance testing, but before releasing the software for beta testing. So the focus of this testing is to simulate real users by using black box and white box technique. The key point is you perform it after acceptance testing, but before actually releasing the product for beta testing. Now, beta testing of a product is performed by real users of software application in real environments. It allows the customer an opportunity to provide inputs to the design, functionality, or it could be usability of a product. Though companies do rigorous in-house quality assurance with dedicated test teams, it's practically impossible to test an application for each and every possible combination of test cases, right? And that is why beta releases make it much more easier to test the application on thousands of test machines and fix the issues before actually releasing the product to market. And alpha testing is performed before beta testing. So yeah, that's the difference between alpha and beta testing. I hope the difference is clear. Let's move on to next question. What are the different levels of manual testing? So be it a manual testing or automation testing or software testing in general, there are 4 levels. First up, you have unit testing, then there's integration testing, after that system testing, and lastly you have acceptance testing. So unit testing is a way of testing the smallest piece of code, which is referred to as unit. A unit is something that can be logically isolated in a system. It can be anything that you want. It can be a specific piece of functionality, or it can be a program or a method in a program, anything. So the main focus here is on the functional correctness of these standalone modules or units. Next up, there's integration testing. It's performed after unit testing when different units, components, and modules of software are integrated together. The focus of integration testing is to check the correctness of communication among all the modules. So in simple terms, you can say that you are checking the interface that's there between the different units or modules. After that, the system testing, it's carried out on a complete, fully integrated software product to evaluate the behavior of the system and then to examine the fully working of an integrated software application according to user requirements. Under system testing, we have different techniques like functionality testing, performance testing, scalability testing, load testing, stress testing, regression testing, and many more. And the last level that we have is UAT, or user acceptance testing, or in simple terms, acceptance testing. It's the formal testing that's performed based on user requirements and function processing. This acceptance testing actually covers end users' real world scenarios. And this last level needs to be done correctly because it provides you with a result on the basis of if the software product is fit to be released to the market or not. So, yeah, these are 4 levels of manual testing. So, the next question that we have is, what's the difference between quality control and quality assurance? We did already talk about what quality control is. Quality control is a set of activities for ensuring quality in the product. So the activities focus on identifying defects in actual product produced. Whereas quality assurance is a set of activities for ensuring quality in the processes by which product are developed. So you get my point, right? Quality control is a product oriented approach. You're checking the quality or defects in the product. Whereas quality assurance is a process oriented approach. You're checking the quality of the process by which products are developed. So, quality control aims to identify defects in the finished product. Therefore, it's a reactive process. Whereas quality assurance prevents defects with a focus on processes which are used to make the product. Therefore, it is a proactive process. I hope the difference is clear. Let me summarize. Quality control is a product oriented approach of running a program to determine if it has any defects, as well as making sure that software meets all the requirements put forth by end user and stakeholder. Whereas quality assurance is a process oriented approach that focuses on making sure that methods, techniques, and processes which are used to create the product meets the quality standard. The next question that we have is, what is a test bed in manual testing? Explain with help of an example. Test bed in simple terms is a test execution environment which is configured for testing. It consists of hardware, software, network configuration, application which is under test, operating system settings, software configuration, test terminals, and much more. So in simple terms, it's a test execution environment which is configured for testing. Well, a typical test bed for a web-based application looks something like this. You have Java version listed out, you have the browser that you're using listed out, operating system settings like Windows or Linux, then the database that you're using, web server, etc. It has all the details which are required for you to perform testing. Next question is, explain the procedure for manual testing. Well, it's quite simple and similar to any other standard software testing. First of all, you start by understanding the requirements which are put forth by the users. Based on the requirements, you write the test cases, and after that, you conduct the test cases that you have written and categorized. Once you have conducted the test and you have your result, you create good bug reports which you will have to submit to your manager or higher level people in the next stage. Simple enough, right? You start with understanding the requirements put forth by the users. You categorize the requirements and write test cases and separate them into different groups to make it much more easier to identify. Once you have your test cases, you execute them, and once you get the results, you create reports and submit the reports to higher authorities. So that's the general procedure that you follow when performing manual tests. The next question is, what exactly is test case? Explain with an example. Guys, documentation plays a very important role in testing, be it manual testing or automation testing. A test case is one of the documentation used. It's a document which has set of conditions or actions that are performed on software application in order to verify the expected functionality of a feature. So basically, test cases describe a specific idea that is to be tested without actually detailing the exact steps to be taken or data to be used. For example, let's say in a test case, your document looks something like this. Quotation, test if coupons can be applied to actual price, quotation close. So that's your test case statement. Let me read it again. Test if coupons can be applied on actual price. So as you can notice, this statement doesn't actually mention how to apply the coupons or whether there are multiple ways to apply or not. It doesn't mention if tester uses a link to apply a discount, or does he enter a code, or does he have a customer service to apply it. It doesn't go into much details. It just specifies the major objective of testing in simple terms. So these test cases, they give flexibility to tester to decide how they want to execute the test. Next question that we have is, what is API testing? API, as you guys might know, is an acronym for Application Programming Interface, which is a software intermediary that allows two applications to talk to each other. So API testing is a type of software testing where APIs or application programming interfaces are tested to check if they meet expected functionality, reliability, performance, and security. API testing is really needed to reveal bugs, inconsistencies, and deviations from the expected behavior of an API. Well, to be honest, API testing offers a lot of advantages, like it's language independent, first of all, and it's graphical user interface independent. It offers improved test coverage, it reduces the testing cost, it enables faster releases, and all that. On top of that, one more thing that you have to remember is basically application is divided into three stages. You have presentation layer, then you have business layer and database layer. So API testing is usually performed in business layer. Let's move on to the next question. Let's see what that is. So what's the difference between verification and validation in manual testing? In software testing, verification is a means to confirm that the product development is taking place according to the specifications and using standard development procedures. It consists of different activities like you have reviews, inspection, walkthroughs, demos, and all that. So basically, you're confirming that the product development is taking place according to the requirement specifications and using standard procedures. Now, coming to validation, it's a means to confirm that the developed product doesn't have any bugs and it's working as expected. It consists of activities like functional and non functional testing techniques. So that's the difference between verification and validation. Moving on to next question, what's the difference between a bug and a defect? So a defect is simply defined as a variance or difference between expected and actual result. It's an error found after the application goes into production. It commonly refers to several troubles with software products with its external behavior or with its internal feature. So the key point is defect is an error which is found after the application goes into production. Coming back to bug, bug is a result of a coding error. An error which is found in the development environment before the product is shipped to the customer. A programming error that causes a program to work poorly, produce incorrect results, or crash the system, that's a bug. Or it can be an error in software or hardware that causes a program to malfunction entirely. Bug is the terminology of a tester. Now you understand the difference, right? Defect is the difference between expected and actual result, and it occurs after the application goes into production. Whereas bug is result of a coding error. Like I said, it can be anything. So it's error that's developed before the product is shipped to the customer. Moving on, the next question that we have is, what are advantages of manual testing? Manual testing has a lot of advantages to offer. First of all, you have live testing. So with manual testing, tester can test the application under similar condition when your application goes live. So any bugs or glitches which occur when application is live can be easily tracked with help of manual testing. Secondly, in manual testing, less programming knowledge is required. Basically, when you're testing on an application manually, your main focus is on understanding requirements, documenting the test cases, and executing the test cases. Then there's this case of UI and UX issues when it comes to automation testing. So basically, automated tests are quite literally robotic, right? They fail to act as a real end user would. But manual testing helps tester to identify any issues which are related to look and feel of the application. It also helps to find out the usability issues in the application. On top of all that, manual testing requires really low investment as it doesn't require any costly tools or highly skilled people to be hired. So what I meant to say is initial investment in manual testing is very low and manual testing is cost effective for short-term projects. Lastly, in manual testing, you can swiftly test and see the outcomes. So it's well suited in cases when you're making lot of unplanned changes to your application and also your application needs to be tested immediately after implementing these changes. In such cases, manual testing is really effective. Let's move on to our next question, which is, what are disadvantages of manual testing? Apart from the pros it offers, it has a lot of demerits as well. First of all, it's really time consuming. Manual tests cannot be reused, which means every time there's a change in your application, the tester needs to run all the test cases again. Well, this is rather time consuming activity. And that is why manual testing is really time consuming. Then you have like testing limitations. You can't go and apply manual testing for performing load and performance testing. See, to check the performance of an application using manual testing, you require a lot of users and gadgets, which again increases the cost of the testing. So it's better to go for automation in that case. And obviously, since manual testing is performed by humans, there's always this possibility of errors. The testing results will be as good as the tester performs the test. That's it. You can't guarantee the quality. With manual testing, there are chances that the tester may miss out the same bugs on retesting the application because it's being performed by human. There's always possibility of that human making an error. So yeah, these are certain disadvantages of manual testing. Moving on, the next question is documentation really necessary in manual testing? Yes, documentation plays a critical role in achieving effective software testing. Well, details like your designs, business rules, requirement specifications, inspection reports, configurations, code changes, test plans, bug reports, etc., all should be documented. Documenting the test cases will facilitate you to estimate the testing efforts that you will need along with your test coverage. It will help you to track and trace your requirements as well. Some commonly applied or used documentation artifacts that are associated with manual testing are, we did discuss one earlier, which is test case. After that, we have test plans, test scenario, traceability matrix, and many more. Well, guys, with this, we've completed the basic level questions. So let's move on to next level, which is advanced level manual testing interview questions. So let's see what's the first question in advanced level category. So what's the difference between manual testing and automation testing? You guys all know the basic difference. Well, manual testing is literally performed by humans or human action, whereas automation testing is performed by human, but with the assistance of tools, scripts, and other things. That being the main difference, let's go ahead and discuss other differences as well. So manual testing, since it's performed by humans, the accuracy and the reliability of test cases are low, whereas automation testing, on other hand, is performed with tools and scripts. The reliability and accuracy is literally high. The time required for manual testing is literally high as human resources perform all the tasks, whereas time required for automation testing is comparatively low as software tools execute the test cases. In manual testing, the initial investment which you make is low because you don't use any kind of tools and all that here, but the return of investment is low as well. Whereas in automation testing, initial investment is literally high, but your return of investments is also high. Manual testing is performed when you have test cases that need to be run only once or twice. Also, when you have test cases suitable for exploratory testing, usability testing, or ad hoc testing. You can use automation for performing regression testing, performance testing, load testing, or when you have cases that need to be tested multiple times. Now, one best thing about manual testing is that it allows for human observation to find out if there are any glitches. And that's why manual testing helps in improving the customer experience. When it comes to automation testing, there's no human observation involved, and that is why it doesn't guarantee the positive customer experience that manual testing guarantees. So these are certain basic key differences between manual testing and automation testing. Now let's move on to our next question. When should you opt for manual testing over automation testing? There are certain key cases or scenarios when manual testing should be preferred. For example, when you have short time projects, automated tests are aimed at saving time and resources, and yet they take a lot of time and resources to design and maintain them. For example, if you are building a small promotional website, it can be much more efficient to rely on manual testing rather than go ahead and create all those automated test cases. Well, it takes time, right? So in such cases, when you're working on small scale projects or projects which take small amount of time, you could go for manual testing. Also, when you have ad hoc testing, in ad hoc testing, there's no specific approach, as in there's no fixed approach. It's a totally unplanned method of testing where the understanding and the insight of the tester is the only important factor. Well, again, manual testing sounds good. Then there's the case of exploratory testing. Even then, manual testing is preferred because in exploratory testing, it requires testers' knowledge, experience, skills, analytical skills, creativity, and mainly intuition. So, human involvement is really important here. Lastly, you have usability testing. So when performing usability testing, go ahead and use manual testing. So when performing usability testing, usually the tester needs to measure how user-friendly, efficient, or convenient the software or the product is to end user. So you should think in terms of end user. For that, again, manual testing is preferred. So these are certain scenarios where you can prefer manual testing over automation testing. The next question that we have is, what are the phases involved in software testing life cycle? Well, it's quite simple. It begins with requirement analysis, where you figure out or categorize the user requirements. Next up, based on the requirements that you've gathered, you plan your entire test life cycle. Once you're sure as to what you're performing testing on, which type of testing you have to perform, and all that, you start developing your test cases. Then set up the entire test environment, which will make your testing more effective. After that, you can start your test execution. And lastly, you have test cycle closure. So let me repeat it again. You begin by analyzing the requirements put forth by the end user. Then you start planning your entire test cycle. Then you develop your test cases, categorize them, design your test environment after that. Basically, you design on different kind of tests that you want to perform, what you want to test on, and all that. Then you execute the test cases that you've created. And lastly, then there's test cycle closure, which indicates the end of your testing cycle. Next question that we have is a really interesting one. What's the difference between a bug, a defect, and an error? We did already discuss the difference between a bug and a defect. Let me go through it again. So, defect is a variance or difference between expected result and actual result detected by the developer after the product goes live. So, defect is an error which is found after the application goes into production. In simple terms, it refers to several troubles with the software product, with its external behavior or with its internal features. Next up, this bug. It's a fault in software that's detected during test time. They occur mainly because of some coding error, which might lead to the entire malfunctioning of a program. They may also lead to a functional issue in the product. So basically, bugs are fatal errors that could block a functionality or result in a crash or cause performance bottleneck. Now, what exactly is error? Error is a mistake, misunderstanding, or misconception on part of software developer. So when I say software developer, it includes software engineers, programmers, analysts, testers, whoever is in contact with the software. So for example, a developer may misunderstand a design notation, or a programmer might just type a wrong variable name, which might lead to an error. Error normally arises in software and it leads to change the functionality of the program. So that's the difference between a bug, a defect, and an error. Moving on to our next question, what actually makes a good test engineer? First of all, a good engineer should have a test to break attitude. That's an ability to take the point of view of a customer. He should have a strong desire for quality and keen attention to detail. Also, tact and diplomacy are also needed, which is to maintain a cooperative relation with rest of the developers that is involved to it. And obviously, it should have an ability to communicate with both technical people, non-technical people as well. So it should have excellent communication skills. And it should have ability to judge the situations and make important decisions to test high risk areas of an application when the time is actually very limited. Along with all this, it's always best to have an experience in software development or testing field because previous experience can be helpful as it provides a deeper understanding of software development process and it gives the testers an appreciation for the developer's point of view. So these are certain qualities that you look for when you're hiring a good test engineer. Moving on to our next question, what is regression testing and when to apply it? A regression test is basically a system-wide test whose main purpose is to ensure that small change in one part of the system doesn't break the existing functionality elsewhere in the system. So if you consider regression testing as an unintended change, then this type of testing is the process of hunting for those changes. So in simple terms, it's all about making sure that your old bugs doesn't come back to haunt you. Let's take a look at fictitious example that illustrates the concept. So when adding a new payment type to shopping website, you have to rerun the old test to ensure that new code hasn't created any new defects or it hasn't introduced or reintroduced any old ones. So regression testing is really important because without it, it's quite possible to introduce intended fixes into system that create more problems that they can actually solve. So how do you actually apply regression testing? It's quite simple. You have tested software, but you'll have to add a new feature. So a feature has been updated. Now you want to check if the new feature has affected or brought out any old bugs, or if it has introduced any new bugs. For that, you perform regression testing. All you have to do is create a regression test plan. Just like how you perform the entire software testing lifecycle, you carry that and you'll have newly tested software with updated feature. Well, that's regression testing. The next question that we have is, what's the difference between system testing and integration testing? It's quite simple. System testing, it tests the entire software application to see if the system is compliant with user requirements and stakeholders' requirements. But integration testing, it tests the interface between the modules or units of software application. System testing, it involves both functional and non-functional testing like sanity, usability testing, performance testing, load testing, and all that. Whereas only functional testing is performed in integration level or integration testing to check if two modules when combined give the right outcome or if they are able to communicate properly through the interface or not. Well, system testing is a high level testing which is performed after integration testing, whereas integration testing is a low level testing which is performed after unit testing. The next question that we have is, explain the defect life cycle. What are the different phases involved? So you guys already know what bug is. We already discussed this many times. A bug is actually an error that could have been introduced in the due course of software development life cycles due to multiple reasons. The common sources of bugs are, it can be ambiguous requirements, programming errors, unachievable deadlines, and much more. Every reported bug actually follows a life cycle till its closure. A bug lifecycle basically illustrates the journey of a bug from the time it is reported to the time it's fixed and closed. So let's quickly go through the steps that are involved in defect lifecycle or bug lifecycle. First step, we have something called new state. Well, in this step, if a defect is logged and it's posted for first time, its state is given as new. Then you have assigned state. So after the tester has posted the bug, the lead of the testing team approves that the bug is genuine and he assigns the bug to corresponding developer and the developing team to solve it. Then it's set to be in assigned state. After that, you have two other status which says open and fixed. So in open state, developer actually start analyzing the bug and start fixing it. Once he's sure that he's fixed the defect, he changes the state of the bug to fixed. Next up, we have test state. So at this stage, tester does the testing of change code which the developer has given back to him. So basically here the tester is checking if the bug which he has assigned to developer has been fixed or not. So once he is verified, he changes the status of the bug to verified. Now, in case if the bug still exists even after the bug is being fixed by the developer, the tester might decide to reconsider the bug. In such state, it goes to reopen state. Now, if the tester thinks that bug is fixed, he marks the status as closed. There's another state called duplicate. In the bug lifecycle, if bug is repeated twice or there are two bugs which deal with the same concept, then one bug status is changed to duplicate. After that, you have rejected and deferred. Rejected is if the developer feels that bug is not genuine, he rejects the bug and the status of the bug is changed to reject. Deferred, if the bug is changed to defer state, it means that bug is expected to be fixed in next few releases. It's quite simple. If you have any queries in this defect lifecycle, you can actually go ahead and refer to software testing tutorial by Edureka. The entire lifecycle is explained in detail. So I expect this concept is much more clear for you guys now. Let's move on to next question. What is a test harness in testing? Explain. In software testing, a test harness or automated test framework is a collection of software and test data configured to test a program unit by running it under multiple conditions and monitoring its behavior and output for all these conditions. So basically, it's a collection of software and test data configured to test a program under multiple conditions by monitoring its behavior and its output. Test harness has two important parts: test execution engine and test script repository. A test harness should allow specific tests to be run. It should orchestrate a runtime environment and it should also provide a capability to analyze the results. Moving on to our next question, what is test closure? Well, test closure is a document which gives a summary of all the tests which are conducted during the software development life cycle, and it also gives a detailed analysis of bugs removed and their errors found. So this document or memo actually contains the total number of experiments, total number of experiments executed, total number of imperfections found, and total number of imperfections settled, total number of bugs or imperfections not settled, total number of bugs rejected, total number of bugs deferred, and so forth. So in simple terms, test closure is a document which has like summary of all the tests that are conducted during entire software development and testing life cycle. Next question that we have is very basic question. What's the difference between positive and negative testing in manual testing? So positive testing means actually testing the application or system by giving valid data, whereas negative testing means testing the application or system by giving invalid data. So positive testing, it determines that your application is working as expected, whereas negative testing, it ensures that your application can run gracefully and it can handle invalid input and unexpected user behavior in a very proper manner. Positive testing is always done to verify a known set of test conditions, whereas negative testing is always done to break the project and the product with unknown set of test conditions. Positive testing checks how the product and the project behave by providing the valid set of data, whereas negative testing checks how the application will actually perform if we provide the invalid output. Will it actually deal with it or give the wrong output, or what would be the result? That's negative testing. So that's the basic difference between positive and negative testing. So next question that we have is define what's critical bug. Well, a critical bug is a bug that's got tendency to affect majority of functionality of a given application. It means that a large piece of functionality or a major system component is completely broken and there's no way to work around it. Application cannot be distributed to end client users if the critical bug has not been issued. Remember that. Moving on to our next question. What is pesticide paradox and how do you overcome it? If same test cases are repeatedly run over and over again, eventually they will no longer will help you find new bugs. And this concept is called pesticide paradox in testing. After a certain number of iterations of testing, as the testing improves, the defect number actually starts dropping and most of the bugs will actually be fixed. So developers will be extra careful in only those places where testers found more defects and they might not look in the other areas. This is what you call pesticide paradox. So how do you actually go ahead and overcome this pesticide paradox? Do you have any solutions? Well, yes. You can go ahead and write whole new set of test cases to exercise different parts of the software, and you can prepare new test cases and add them to your existing test cases. So by following above two methods of prevention, it's possible to find more potential defects in the area where you might have actually missed previously or where you might have neglected before. So that's what pesticide paradox is and how you overcome it. Moving on to our next question. What is defect cascading in software testing? So defect cascading is process of triggering other defects in application. Simple, right? It's just triggering other defects in application. When a defect goes unnoticed while testing, it invokes other defects. Well, as a result, multiple defects crop up in later stages of development. If defect cascading continues to affect other features in your application, identifying the actually affected feature becomes very challenging. You might actually go ahead and take different test cases to solve this issue, even when it's difficult and time consuming. Let me give you a simple example to understand the concept. So an application is being deployed to calculate a monthly salary of the employees. The module which is responsible for calculating salaries is having an unidentified defect. As a result, it's wrongly calculating the salary. This prompts the database to transmit incorrect salary numbers, which are further reflected in your balance sheet, tax calculations, and wherever the salary part is used. So one defect is triggering other defects in application. That's what defect cascading is. Let's move on to our next question, which is, what do you actually mean when you say a quality software? So in general, quality software is reasonably bug-free. It's delivered on time and within budget. It meets the given requirements or expectations, and it's highly maintainable. But again, quality is always a subjective term. It will depend on who the customer is and their overall influence in the schema of your testing. For example, each type of customer will have their own slant for quality. The accounting department might define quality in terms of profit, whereas if you ask a general end user, he might define quality as user friendly, safe, and bug free. So again, quality is a subjective term. The next question that we have is, what is black box testing and what are various techniques that come under black box testing? So black box testing is also known as specification based testing. It analyzes the functionality of the application without knowing much about the internal structure or design of the application that's being tested. So what's the purpose of black box testing? Well, it's to check the functionality of the system as a whole to make sure that it works correctly and it's meeting the user demands. You have various techniques that pop up under black box testing, like you have equivalence partitioning, use case testing, cause effect graphing, and many others. The next question is also somewhat similar to that. What is white box testing and what are various techniques? White box testing is also known as structured based testing. It requires a profound knowledge of code as it includes testing of some internal structures a part of application. So unlike black box testing and white box testing, the tester need to have some sort of knowledge regarding the internal architecture of the application that he is testing. The purpose, if you ask, is to enhance the security, check the flow of input output through application, to improve the design, usability, and all that. Various techniques that come under white box testing are you have decision coverage, statement coverage, condition coverage, multiple condition coverage, and many others. Another question based on the same concept is what are experience based testing techniques? Experience based testing is all about discovery, invention, intuition, and it's all about learning. So the tester constantly studies and analyzes the product and accordingly applies the skills, traits, experience to develop a test strategy and design test cases. So various techniques that come under this category are exploratory testing and error guessing. The next question that we have is what's the difference between top down and bottom up approach? Well, it's all there in the name of the term itself. In top down approach, testing happens from top to bottom. That's high level modules are tested first and after that low level modules. And lastly, low level modules are incorporated into a high level state to guarantee that framework is working as it's supposed to do. Similarly, in bottom up approach, testing happens from base levels to high up levels. The lowest level modules are tested first and after that high level modules. And lastly, high level modules are incorporated to low level state to see if the framework is working as expected or not. Moving on, we have what's the difference between smoke testing and sanity testing? It's quite simple. The concept of smoke testing and sanity testing is very similar, except smoke tests are executed on initial builds of software product, whereas sanity testing are tests which are done on the builds that have passed smoke test and other rounds of regression test. So what's the motive of smoke testing? It's to measure the stability of newly created builds so that it can go for more rigorous rounds of testing. What's the motive of sanity testing? That's to evaluate rationality and originality of the functionalities of software builds. Another main difference is that smoke testing involves a lot of documentation and scripting work, whereas sanity testing doesn't emphasize any sort of documentation. Smoke testing is a shallow and wide approach to include all major functionalities without actually going much deep, whereas sanity testing is narrow and deep approach and it involves detailed testing of functionalities and features. Smoke testing is executed by developers as well as testers sometimes, whereas sanity testing is executed only by testers. We have another difference based question, which is the difference between static testing and dynamic testing. So static testing is a white box testing technique. It includes the process of exploring the records or documents to recognize the imperfections in early stages of software development lifecycle. The key point is static testing is performed in the early stages of development lifecycle to recognize imperfections. Dynamic testing, it includes a lot of execution of code and it's done at later stage of software development lifecycle. It validates and it approves the output with expected results. Static testing is usually implemented at verification stage, so that's early stages, whereas dynamic testing usually starts during validation stage. Static testing is performed before the code deployment and dynamic testing is performed after the code deployment. Another important thing is code error detection and execution of program is not much of a concern when it comes to static testing, whereas execution of code is really necessary when you're performing dynamic testing. So these are some key differences between static testing and dynamic testing. So guys, with this, we have come to the end of advanced level questions, or you can say theory based questions. Now let's go ahead and deal with some real world scenario based questions. So the first question that we have under this category is how will you actually go ahead and determine when to actually stop testing? Deciding when to stop testing can be really difficult. Many modern software applications are so complex and they run in such interdependent environment that complete testing can never be done. You agree with me there, right? So some common factors that you can consider when you're facing difficulty to decide on when to stop your testing are that you can go ahead and consider the deadlines, which are release deadlines, testing deadlines, and all those. And suppose if you have test cases which are completed with certain pass percentage, then maybe you can go ahead and stop testing after you think that the amount of pass percentage is enough. Or when your test budget is completely depleted, well, again, that's another reason to stop testing. Or when coverage of code or functionality or any other requirements reaches a specific point, or when your bug rate falls below a certain level that you can no longer proceed with testing, or when your beta or alpha testing period actually ends. Well, these are certain simple ideas that can help you decide when to stop testing. Moving on to the next question, what if the software is so buggy that it cannot be tested at all? Often testers encounter a bug that cannot be resolved at all. In such situations, the best thing is for testers to go through the process of reporting whatever bugs they find and focus mainly on critical bugs. Well, since this type of problem can cause other issues like insufficient unit testing or insufficient integration testing, poor design of an application, improper build or release procedures, etc., the higher authorities or managers should be notified and they should be provided with some sort of documentation as a proof or evidence of the problem, saying that so and so bug has come up and we are facing an issue where we are not able to solve this bug at all. So in that way, they should provide some sort of documentation as an evidence or proof to their higher authorities saying that bug is really not testable at all. Moving on to the next question, how you actually test a product if the requirements are yet to freeze. It's possible that a requirement stack is not exactly or not available for a piece of product sometimes. It might take serious effort to decide if an application has significant unexpected functionality, and obviously it would indicate deeper problems in software development process. So what do you do in such situations? So if the functionality for this for which requirements are not there isn't necessary for functioning of your application, maybe you can actually remove that functionality. Well, if you think that functionality is really necessary, then go ahead, create a test plan based on the assumptions that you have made about the product. But again, make sure that all the assumptions that you've made, you get it right and they are well documented in the test plan. Moving on to next question, what if an organization is growing so fast that fixed testing procedures are impossible? What do you do in such situations? Well, this is a very common problem which is faced in software industry, especially considering the new technologies that are being incorporated and some that are being popped up very now and then. So there's no easy situation or solution for the scenario. You can actually go ahead and hire very skilled and good people to deal with the situation. Or management should actually ruthlessly prioritize quality issues and their main focus should be put on customer. And everyone in the organization should be clear on what actually quality means to them. So these are certain solutions that they can adopt in a situation where they actually think that the fixed testing procedures are no longer plausible or can be applied. Next question that we have is, how do you know that the code has actually met the specifications? So when I say a good code, it doesn't have any particular definition. In simple terms, good code is code that works, that's bug free, it's readable, and highly maintainable. So most organizations have their own coding standard that all the developers and testers are supposed to stick to. But everyone has different ideas about what's best, what's too many rules, and what's very few rules. So there's no fixed thing as good code or anything. Well, honestly, there are a lot of tools these days that can help you check if your code is sustainable, if it's good, or if it is met specifications. For example, you have something called traceability matrix, which ensures that all your requirements are mapped to the test cases. And when the execution of all the test cases finishes with success, it indicates that the code has met your requirement. So you can go ahead and use such tools to see if your code has met the specifications or not. Let's move on to our next question. So, what are certain cases where you consider to choose automated testing over manual testing? Automated testing can be considered over manual testing during multiple situations. For example, when you have test cases that require periodic execution, when the tests include repetitive steps, When tests need to be executed in a standard runtime environment, you can go ahead and adopt automation testing rather than manual testing. Also, when you have very less time to complete the test phase, when there's a lot of code that needs to be repeatedly tested, and when there are reports that are required for every execution, then actually you can go ahead and use automation than manual. So the next question that we have here is quite interesting. What's configuration management? So every high functioning organization has a master plan, right? That details how they're supposed to operate and how they're supposed to achieve their goals and all that. Well, software development and testing are no different. Software configuration management, or SCM, is a set of processes, policies, and tools that organize, control, coordinate, and track code, different documentations, problems, change requests, designs, tools, compilers, and libraries. Well, you can call it as a master plan for testing. Next question is it true that you can actually go ahead and do system testing at any stage? System testing, all the components of software are tested as a whole in order to make sure that overall product meets the requirements specified. So, no, system testing cannot be performed at any stage. It can only start if all the units or modules are in place and are working individually properly. And another thing is that system testing actually happens before you perform user acceptance testing. Next question is, what are certain best practices that you should follow when writing test cases? When you're performing testing on a large scale, you have like thousands of requirements to consider. And if you go ahead and write your test cases randomly, it will become difficult for you to track later on. For that very reason, you have some practices that you can go ahead and follow, and it will make you much more easier to keep track of your test cases. So first of all, prioritize which test case to write based on the project timeline and the risk factor of your application. Always remember the 80-20 rule. So to achieve best coverage, 20% of your test should cover 80% of your application. That's 80-20 rule. So don't try to test all the cases in one attempt. Instead, improvise them as you progress. List down your test cases and classify them and separate them based on your business scenarios and different functionality. Make sure your test cases are modular and your test case steps are as granular as possible. Another thing is that write your test cases in such a way that others can easily understand them and modify them if required. Always keep end users' requirement in back of your mind, because ultimately the software product that you're testing or designing is for the test end users. Well, always remember using a test management tool to manage stable release cycle. Monitor your test cases regularly, write unique test cases, and remove irrelevant and duplicate ones. Moving on to our next question, why is that boundary value analysis provides very good test cases? So the reason why boundary value analysis provides good test cases is that a greater number of errors actually occur at boundaries rather than in the center of the input domain for any test. So basically, in boundary value analysis, test cases are designed to include values at boundaries. And that's why boundary value analysis provides very good test cases. So if the input is within the boundary value, it's considered positive testing. And if your input is outside of your boundary value, it's considered negative testing. So when I say boundary value analysis, it includes different values like maximum, minimum, inside or outside edge, typical values, or error values. Next question that we have is, why is it impossible to test a program thoroughly, or in other terms, 100% bug free? Guys, it's impossible to build a software product which is 100% bug free. You can just minimize the error, flaws, or failures or faults in your computer program or system which cause it to produce an unexpected result. But it's impossible to make it 100% error free. Well, here are some two principal reasons that make it impossible to test a program entirely. First of all, software specifications and requirements can be subjective and they can lead to different interpretations. Secondly, a software program might require too many inputs, too many outputs, and too many path combinations to test. Well, these reasons make it impossible to test a program entirely. So the last question that we have is, can automation testing replace manual testing? Automation testing isn't a replacement for manual testing. No matter how good automation tests are, you cannot actually go ahead and automate everything, right? Manual tests play a very important role in software development and they come in handy whenever you have a case where you cannot apply automation. So, automation and manual testing each have their own strengths and weaknesses. In simple terms, manual testing helps you to understand the entire program or problem and explore the functionality of your feature or applications from user's perspective, or in other words, with more flexibility. On the other hand, automated testing helps save time in long run by using a lot of tools and techniques and scripts. So like I said, both of them have their pros and cons. So automation testing isn't actually a replacement. It's another way of performing software testing. Well, that's my opinion. If you have different opinion or if you agree with me or no, please do put them in the comment section below. It'll be interesting. Well, that's it guys. With this, we have come to the end of the session regarding manual testing interview questions and answers. I hope you found it informative and interesting. If you have any queries or any doubts, please do put them in the comment section below and we will get back to you as soon as possible. Thank you guys.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!